Welcome to our comprehensive analysis of large language models, or LLMs. We'll explore the technology that is rapidly transforming the digital landscape. In this first section, we'll set the stage by defining what large language models are and why they are so important today. Large language models are powerful AI systems trained on massive amounts of text data, enabling them to understand, generate, and process human language with unprecedented accuracy. The historical development of LLMs is a story of continuous innovation, leading to the sophisticated models we use today, capable of complex language tasks. Next, let's explore the core technical foundations that power these advanced language models. At the heart of modern LLMs is the transformer architecture. This is the foundational structure that allows for highly efficient processing of sequences, which is crucial for handling language. Key mechanisms like self-attention and parallel processing enable LLMs to weigh the importance of different words in a sequence, leading to emergent reasoning capabilities across various complex tasks. Understanding how LLMs are trained is essential to appreciating their power and limitations. The multi-stage training process for LLMs is intensive, involving initial pre-training on vast datasets, followed by fine-tuning steps to optimize performance for specific tasks. Crucially, achieving alignment ensures that LLMs provide outputs that are safe, useful, and adhere to ethical standards, mitigating potential risks from unconstrained models. LLMs aren't just theoretical, they are transforming industries through practical, real-world applications. LLMs demonstrate remarkable emergent reasoning across diverse tasks, from complex coding and advanced translation to sophisticated content synthesis, going far beyond simple pattern matching. From personalized customer service in e-commerce to accelerating research in healthcare and advanced data analysis in finance, LLMs are proving indispensable. Advanced applications utilize LLM agents for automated tasks and retrieval-augmented generation, or RAG, to ground responses in external, factual knowledge bases, enhancing accuracy. Despite their potential, LLMs face several critical challenges that must be addressed for responsible deployment. A major challenge is addressing hallucinations and factual errors, where the model generates misleading information that sounds convincing but is factually incorrect. Systemic bias, often inherited from training data, presents ethical concerns, requiring continuous efforts to ensure fairness and prevent harmful outcomes across different user groups. Furthermore, the extensive computational requirements for high-scale AI infrastructure contribute to a significant environmental impact, demanding more energy-efficient models and training processes. In conclusion, LLMs represent a powerful, evolving technology. Addressing current challenges while expanding their capabilities will define the future of artificial intelligence and its role in our world.